Hey, look, I got got the keyboard off. And I got some parts out over there, the wireless card memory and hard drive and stuff. And now this right here is the video card chip, that green card. That's the chip. This card underneath here, that big block square thing, that's actually a chipset. That's what is the bridge between the processor. The processor communicates a chipset which communicates to the RAM, which was right there, get the stick out. And that chip also communicates with every other device on the motherboard. So it also communicates with the video card, it communicates with your modem card, your wireless card, your CD-ROM, the hard drive, which is underneath here, communicates with everything. That chip is so important. Now, one thing that's unique about your model is they have a problem fixed. It's this little arm right here, the screw. What this does is, well, when copper, which is the heatsink here, when this gets hot, well, copper expands into tracks. And because there's pressure on these four screws here that hold it to CPU, this will actually lift up and go down. And when it lifts up, it disconnects from the chipset for the video card. So they put this little arm here that acts as like a little spring, and it pushes down on the copper to keep it so it doesn't bend up. And these are actually vacuum sealed. They're in a vacuum, and then there's like I forget what they use, like nitrogen or whatever gas inside, and it's in a vacuum. So, but it's actually they call these vapor tubes or heat pipes. And what these do is the gas. Sorry, it's not a vacuum. It's compressed. It's under pressure. It's at a point where the gas is actually in a liquid form, but it's almost at its point to where it turns back into a vapor. So, just like water boils at 100 or 200 degrees, if you put water inside of a vacuum, it'll boil at a lot lower temperature. That's why in higher elevations you need less temperature to boil water, and that's the same feature here. Now, when water boils, let's say you put it in a paper cup, and you put a small flame under the paper cup, the paper is not going to burn because the water is boiling. It's going to take all the heat from the paper. There's the same feature here. The vapor here will boil, and it'll go to this side to where it's cooled, and it's going to go back to the, so it goes in a U shape. And essentially the hotter it gets, the hotter this thing gets over here, so the fan can blow the heat out. And this is designed by a company called Zolman. They're a Korean company. They actually developed this technology, and then they sold rights all over the world. But it's, anyways, that's what this is. And so in a nutshell, that's kind of how it works. You can Google it, watch videos, and they kind of sort of explain it, but some people get all technical and woohoo, wish-washy, whatever. But the processor you have is actually quite nice. It's upside down. It's a 2.53 gigahertz. 6M means it has 6 megabyte cache. And the 1066, that's the bus speed. So it's a 1066 bus, which is pretty good. So, and I think they make a 2.6 or a 2.8 that works on this. So, but anyways, to get the fan out, we have to get this out. And my battery is almost dead on this, so I can't walk you through every single step. But what I'll do here, and I also found out why it doesn't lock, and I'm going to fix that when I put it back together for you. To get that thing off, we need to get off the screws here. I took the two off here. We need this one and these two off, and then that bottom part will pop off. So I'm going to do that real quick, and then I'll get back to you.